Okay, hi everyone. We are working on a new chapter today, completely new topic. We are going to be discussing the number E and then ln, that's an L. We actually pronounce this ln. Now, ln is a special type of log. We are going to discuss all of that now. Hopefully you guys watched the video that I linked on what the number E actually is and all the different places in which it can appear. If you didn't watch that video, basically it is just it's like pi essentially. It is a constant, it's a number that is just represented by the letter E because it appears in so many different mathematical scenarios that it's easier to just assign a specific letter to it as opposed to actually just using the non-recurring decimal number when using it in calculations. So there is actually an E button on the calculator as well. If you look at the ln, so just underneath the log button, you can see that there's a ln button. All right, so that is what we're going to be using when we work with ln. But just above that button, you should see in orange, it says e to the power of. So if you say shift and that button, you are able to do calculations with the number e. All right, so I'm not going to go into all of those various applications or uses of the number e. We are going to work with e in terms of derivatives and integrals specifically, but not really anything else. So yeah, it's just in case you want to know where it comes from and what it is about. It is, I think it's like 2,7. Yeah, let's add that to the top of to the heading here. E is, I'll say approximately, say 2,71828. All right, and then yeah, there are more decimals, but that's an approximate value of e. Just like pi is 3,14 blah 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 blah, e is approximately 2,7. We can say 2,718, all right, or 2,72, depending on what the question is using. But again, if we use the e button on the calculator, it uses the full number e, so we don't have to actually type this in. Right. We are just quickly going to revise the laws of exponents, and then we're going to go over the laws of logs. Now, log laws have been taken out of the core syllabus. They were taken out a few years ago, but we do work with log graphs in core later on, in term 1 actually, when we do inverse graphs. Now, you guys have already done inverse graphs in grade 11 in AP. I actually can't remember if we did log graphs. A log graph is an inverse, or is the inverse of an exponential graph. Can't remember if we touched on that. That was when I was on leave. But yeah, we are going to go over all of that stuff again, and then we're going to go over it in core as well. So don't stress if we didn't speak about it last year. So the laws of exponents, you should all know these laws, for example, and now we're just working with e because the chapter is about the number e. So e to the x times e to the y, we should know that we can simplify that to e to the power of x plus y, right? You add those exponents together. If you have e to the x divided by e to the y, that can be written as e to the x minus y. Then e to the x in brackets to the power of y, we know that we then multiply those exponents together. So we're going to have e to the power of xy, or x times y. A times e, all in brackets to the power of x, is a to the x times e to the x. And then this last one isn't actually a law of exponents, but it is just, it just has to do with going from exponential form, to log form, because we are going to use it in the examples and in the exercise. So if you have a to the power of x is equal to y, all right, we did do this last year. Did we? I actually can't remember if we did. I feel like we did. Correct me if we didn't. It does feel to me like we did. Yeah, I'm confused with the matrix from last year and with you guys. Just, yeah, if we didn't, this is how it works. It's a different way of writing the same equation. So say, for example, you have something like, let's do 3 to the power of x is equal to 101. All right. In grade 10, we would have used trial and error to find that, to solve for x now if we had to. But now, using log form and the log button on the calculator, we can actually rewrite this equation in log form, which will then allow us to use the button on the calculator to solve for x. All right, so how it works is the exponent, that's the thing that we're trying to solve for. That's the purpose of logs. The purpose of logs is making the exponent the subject. So we're going to change it to x equals, all right, now the base of the exponent becomes the base of the log. So we're going to have log base 3. So the 3 is written, it's almost like it's a subscript of log. And then the other number is just the number after the base. So 101. Okay, now we can actually find that answer without having to do trial and error. So now we're just going to say, we're going to use the log button, we're going to type in 3 and we're going to type in 101. Oh, sorry, equals, there we get 4.2. All right, so that means that x in this case is actually 4,2. Right, so that is where logs are actually very useful, and the log button is very useful. If you have an exponential equation that you can't solve by using the normal, because if this was 3 to the x equals 9, right, then you would say 3 to the x equals 3 squared, so x equals 2. So if you can't solve it in that way, you have to rewrite the whole equation in log form and then solve for x from there. Okay, so we're just going to write this as a rule, as a law. If you have a to the x equals y, we can rewrite this in log form. Remember, the purpose of logs is to make the exponent the subject. So x is equal to log, now the base of the exponent becomes the base of the log, so log base a of y. Okay, so that's how it works. Now from there, we are going to go through the log laws. You do have to know these laws. They can ask you to find, or they can ask you to use them to solve some questions. We are going to do some examples and exercises on it. So the first one is if you have log base a of a product, so here we have x times y, then you can actually rewrite this as the sum of two laws. So this is similar to the exponent law, where we have the product of two powers, and then we rewrite it with the same base, but we're just adding those exponents. So now we're going to rewrite this product as two logs that we're adding together. All right, so this is going to become log base a of x plus log base a of y. So we keep that same base, just like when we are working with exponents. We keep the base the same. We just change it into adding. Okay, so if you know this, you can kind of use this exponent law as almost like a memory trick to help you remember this one. And then obviously you can go the other way around as well. If you have two logs with the same bases that you're adding together, then you can write it as one log with that base and the product of the numbers that follow the base. All right, I'm sure you guys can guess what this is going to become. Just like when we're dividing powers with the same bases, then we subtract those exponents. Now we are dividing a log. Well, we're dividing the numbers after the base of a specific log. So now we're going to change this into minus as well. So we're going to say log base a of x minus log base a of y. We are going to do examples where we use all of these, so don't stress if it doesn't make sense to you now. Okay, so when we're multiplying them, we can split it up and then we can add them together. When we divide them, we can again split it up and minus. Right. Next up, this one is actually called the power rule. I'm just going to write it there at the bottom. Okay, and that is when you have a log, and in the number that follows the base, this number doesn't have a specific name, by the way, that I know of. If any of you can find a specific name, that would be quite nice if you want to do some research for me. But yeah, I've never come across a specific name for this number. So here, if you have x to the m, all right, anything that maybe can be written as a number with an exponent. We are going to practice it, like I said. But here, what you're going to do is you're going to take the exponent and you're going to write it in front of the log. So you're going to change that exponent to a product, essentially. So this is going to become m times log base a of x. Right. Now, number 4, this is one that doesn't really come up often, and this is almost a bit of a manipulation kind of rule. So I think we will probably do an example of this. Let me just see if there are any examples. It doesn't actually even look like there are any examples. Yeah, this is kind of just like a trick. I'll see if I can find an example or two on using this for a later video perhaps. If you have log base a of x, all right, and it's in an expression that you're needing to simplify and you're stuck, you can't do anything, you can change this into something that could potentially be useful. So in the same way that we sometimes change 1 to, or that we sometimes change tan to sine x over cos x. All right, we do that so that we can use it. It's a similar kind of concept where we're going to change this. If we're stuck, we have nothing that we can do in our expression that we're needing to simplify or our equation that we're needing to solve. We can change this. We can actually rewrite this as log, and now we are kind of inventing a different base. All right, so that can be any base depending on the question, depending on what you're needing in your expression or in your equation. So we're going to invent a new log. We're going to say log base b, whatever that may be, of x, so of that number. All right, the number that comes after the base, so the bigger number, if you want to call it that, over log base b of a, which was the original base. Okay, so that's a bit tricky, that's a bit difficult to remember, but I'm just going to go through that again. If you have an expression or an equation, or maybe one of those things where you're needing to prove that the left-hand side is equal to the right-hand side, and you're stuck, you have a log with a specific base and a number there. You need a log with a completely different base from the one that you've been given. You can change this into log of x over log of a, so log of the big number over log of the base, but then you need to invent a new base of that log. All right, so the base originally was a, now the base is b, so that can be any base as long as you take the same base at the top and at the bottom. Okay, again, I'll see if I can find an example of that, so don't stress about this too much, but this one is a manipulation law. Okay, that's not the proper name of it, but that is when we'll use it, when we need to manipulate the expression or the equation that we have into something else. All right, then, so this is almost like a trick. Right. These next two ones are not really laws. They actually come from exponent, things that happen when you have exponents, but the log base a of a, is always equal to 1. So whenever you have the same base and number following the base, the answer when you simplify it will be 1. So I can just show you a couple examples here on the calculator. If we have log base 2 of 2, our answer is 1. Log base 7 of 7, the answer is 1. Log base 10 of 10, the answer is 1. Log base 179 of 179, the answer is 1. Now the reason for that, I'm just going to do it on the side here. If we wanted to rewrite this in exponential form, okay, here we went from exponential form to log form. So let's just recap what we did. When you have your equation written in exponential form, the exponent becomes the subject. So here that means that the subject will have to be the exponent. I'm going to say that again. The exponent becomes the subject. So here the subject will have to become the exponent. So we're going to have something to the power of 1. The base of the exponent becomes the base of the log. So the base of the log will have to become the base of the exponent. So we're going to have a to the power of 1. And that is then equal to the other number. And isn't that true? A to the power of 1 is 1. Any number to the power of 1 will always, a to the power of 1 is a. I misspoke there. any number to the power of 1 will just be that same number, right? A to the 1 is equal to 1. 2 to the 1 will be equal to 2. I said 1 again. Sorry, a to the 1 is equal to a. 2 to the 1 is equal to 2. 10 to the 1 is equal to 10. And if we rewrite this equation in log form, this is what we get. And this will always be true. If you have the same base and number following the base, then the log of that combination will be equal to 1. In a similar way, if you have log of any base of 1, your answer will be 0. And again, we can look to exponential laws to prove that. The expression, the subject will become the exponent. Base of the log becomes the base of the exponent. So a to the 0. And we all know that a to the 0 is equal to the last number there equal to 1. Right, so moral of the story, you can have any base there. If the number following the base is 1, then the answer will definitely be 0. Okay, so those are all the exponent laws, all the log laws, and also how to go from exponent form to log form. Now what I want us to add to this arrow is another arrow on the left-hand side. What this now actually means in mathematical speak, I think I've told you guys before that the one-sided arrow, the one that it was originally, means then if you have this double-barreled arrow, I suppose, it means that you can go in either direction. Right, which is true. You can go from exponential form and rewrite it as log form, as we have here, or you can go from log form and rewrite it in exponential form, as we have there. Okay, so this is an arrow that we also could possibly use going forward, and I just wanted you guys to know what that means. Okay, we're going to do some examples. So let me just write here at the bottom. Examples. Write the following as a single log and simplify. So I'm just going to say here, write as a single log and simplify. Okay, so something that I forgot to mention actually, which is quite important, is log with a base of e is ln. Right? Obviously there would have to be something, a number there, and it will then be the same number there. But that is what ln is. Okay, it's a special form of log. So log base e is ln. Okay, we don't ever write log base e. I suppose it wouldn't be wrong if you did, but you'll never get a question that has log base e. It will always be ln. So now, of course, ln is a specific type of log, so all of these laws will apply to ln as well. So this one, for example, I just want to bring our attention to this one. Log base a of a is equal to 1. If you have the same base and number following the base, it will be equal to 1. That means that ln of e will be equal to 1, because ln, let me just fix that L there, ln is the same as log base e of e, then it will be equal to 1. Right, so all of these laws will work for ln as well, because ln is just a special log. It's a log with a base of e. All right, so we're actually going to work with ln for all of these examples now. So the first one is 1/3 of ln 8 minus ln 2. Okay, now this is kind of similar to when we worked with surds last year. I'm sure you guys remember when we added and subtracted surds, we always tried to get the same surd so that we could work with like surds so that we could simplify. It's going to be the same kind of concept here. We have a ln 8 and we have a ln 2. All right, we want to get them to be the same ln so that we can write it as a single log and then simplify from there if possible. Okay, so what I would suggest that we do is 8 is the same as 2 cubed, right? So that's what I'm going to do. I'm going to rewrite ln 8. So we have a third. Then I'm going to rewrite this as ln 2 cubed. Right? See what I'm doing? I'm just writing this number as that same number so that we at least are kind of working towards having the same logs, the same ln. Right? Minus ln 2. Now if we look at the power rule here, law number 3, if we have an exponent there, we can write it in the front. Okay, so we can say 3 times a third ln 2 minus ln 2. Now from here, what is 3 times a third? 1. So we essentially have ln 2 minus ln 2, right? You wouldn't really have to write that, but I'm just going to write it so that we remember. And what is that? That is just 0. Okay, not bad. Now what they did in the textbook, in the answer series, is instead of doing this 2 to the 3 and then taking the 3 to the front, they use the power rule in reverse. So if you look at this here, you have a number multiplied by the log. You can take that number and you can make it the exponent. So what they did, I'm just going to write their method on the side because it might be useful to just see different methods. So they went from here and they changed this to ln, and we can do 2 to the 3, but they then made that 1 over 3 into the exponent from there. Now what's going to happen here? 3 times a third is just 1. Right, so we're ending up with ln 2 either way. Then they still had minus ln 2. Right, now this is quite straightforward again. Ln 2 minus ln 2 is 0. But what they actually did in the textbook, I suppose just to give you exposure of working with the laws as well, they worked with law number 2 in reverse. So if you have a log with the same base of x minus log with the same base of y, you can change it into one log. Oh, and I suppose that would actually be following the instructions, hey? So my method here is actually incorrect because I didn't write it as a single log before I simplified. I had 2 logs, which I then simplified. Okay, so sorry, that is actually the key here. So this is actually problematic. All right, so what they did here, let me just rewrite this, ln 2 minus ln 2. Okay, so this isn't wrong, it just wasn't following the instructions. Right, my bad, learn from my mistake. So now we need to write it as a single log, so they use the second law there, where if you're minusing, you can write it as 1 log. And these 2 logs do have the same base, right? They're both ln, so they both have a base of e. So we can do this. So ln of 2, that one, the first one minus the second one. So the first one divided by the second one. So ln of 2 over 2, which is ln of 1, which, if we remember the 6th law there, any log, of 1 is equal to 0. Okay, and guys, if you forgot that, you can use the button on the calculator and you can literally just say ln of 1 is equal to 0. Okay, you will get your answer there.